Ever pondered why sampling methods matter so much in research? It's because they form the backbone of every study, ensuring that collected data is representative and reliable. Beginning with probability sampling, this method is like a fair lottery. Every member of the population being studied has a known and non-zero chance of getting picked. Whether it's a study on the social habits of millennials or a survey on the voting preferences of a city, each individual stands an equal chance of being selected for the sample. Under the umbrella of probability sampling, there exist several methods like simple random sampling, systematic sampling, stratified sampling, and cluster sampling. These techniques, though different in approach, share the same foundational principle: randomness. This randomness is a researcher's best ally, as it allows for the calculation of the probability that any given sample accurately represents the population. The results obtained from probability sampling can be generalized to the entire population with a known level of confidence. This ability to generalize is a significant advantage, making probability sampling a cornerstone in many research studies. Moving on to non-probability sampling. Unlike its counterpart, this method doesn't rely on the random selection of participants. Instead, it's based on the researcher's judgment or convenience. Imagine a researcher trying to understand the impact of a new medication. They might choose to sample patients in a particular hospital ward, not because they were randomly selected, but because they were readily available and fit the study's criteria. Non-probability sampling envelops methods like convenience sampling, quota sampling, purposive sampling, and snowball sampling. These methods are often employed when obtaining a random sample is challenging, impractical, or when resources are limited. However, there's a catch. Results from non-probability sampling cannot be generalized to the entire population with the same level of confidence as probability sampling. This lack of generalization is a trade-off researchers often have to make when using non-probability sampling. In essence, probability sampling ensures that each member of the population has a known chance of inclusion, providing a high level of confidence in the results. On the other hand, non-probability sampling, while more convenient and practical in certain situations, does not guarantee this level of confidence. Sampling methods, as mundane as they may seem, are the threads that hold together the fabric of research. They ensure that the data collected is a true reflection of the population, providing a solid foundation for meaningful insights and impactful decisions.